Yeah, hello, welcome to our talk. I'm Ollie and there's Stefano with me. Yeah, we're going to talk about Coconut-SVSM and early attestation to unlock persistent state. Yeah, so again, super quick intro to what confidential computing with an SVSM looks like. So we have hardware that provides us confidentiality of the guest. So the hardware encrypts the memory and the CPU state, so that the untrusted host and or hypervisor can't access this. Yeah, remote attestation is employed to confirm the initial state of the virtual machine and to know that we're running in the software that we want in the environment that we want. A launch measurement covers the initial state that we then can verify. So the data in use is protected by the hardware, and the data at rest, there the guest operating system has to take care of itself and use disk encryption. Yeah, we have the SVSM, which runs isolated from host and guest in a special privilege level. Yeah, and it can be used to provide security critical services to the guest, for example, a virtual TPM device. So goals from the end user perspective. So what we want to see is that we want to make it super easy to transition from regular VMs to confidential VMs. So ideally, the guest operating system doesn't need to change much and can mostly stay unmodified. We want to also focus on long-living guests that live for a long time, get restarted, updated, and have a persistent bootable disk. Yeah, ideally the guest operating system has very little to do with attestation and other confidential specific things. And we want to support measured boot and secure boot. Yeah, because this is what lots of customers expect. Yeah, how does it look right now? So Linux and OVMF, so the UEFI firmware already work with an SVSM, and Coconut-SVSM provides an ephemeral virtual TPM. Its state is reset or on each boot, so it's remanufactured, and that means that its identity changes every time its monotonic counters are not preserved, and the non-volatile state is also reset. This is still useful. For example, you can use it for collecting PCR measurements, but what it doesn't work is unsealing secrets with it. For example, you have full disk encryption keys. This doesn't work because this includes the TPM identity, which is not preserved. Another thing is that the UEFI variable store currently is also not preserved. And also starts up empty. So you can't really configure secure boot right now. It's not really possible to implement a secure variable store in this scenario right now because we don't have the secure management mode, which is usually used to protect the variable store. So with this, now we have the questions like how do we boot the guest? How do we unlock the disk? And when and how do we want to do the remote attestation? So if we want to provide a fully functional TPM and preserve all of its state, and if we want to and we also want to provide a functional EFI storage, this could be implemented, for example, by putting a little variable service into the SVSM, which then OVMF can talk to, and then we can manage the access policies there, because OVMF can't do this, as I explained before. So and to make all of this work, in the end, we need to persist the state that, or all the data that the SVSM has, and it needs to be stored across the reboot somehow. So again, so the state is the vTPM state and the UEFI variables and maybe some other things that might come in the future. And the idea now is to add a little storage driver to the SVSM, which then can store data on the host provided storage backend. Of course, we need to use an encryption layer because the host can't be trusted. yeah, and maybe we even have to implement multiple storage drivers to provide all the different hypervisors that might have different backends there. Yeah, and now the question is, how do we want to decrypt that SVSM state file on booting? And Stefano.
Okay, so now we have encrypted state. What we need to do, we need to have a key to decrypt it. So in order to unlock it, yeah, the answer is we need to do a remote attestation. I will go pretty fast because, yeah, we already heard a lot of remote attestation. So what we need to do an early attestation in SVSM. So we need to generate an evidence from the hardware, send the evidence to a remote server, which is trusted. It works in a trusted environment, and that the server validates the evidence, so check that the software is the expected one, runs on a genuine hardware, and we'll check other parameters. And then when everything is fine, the server will send back to SVSM the key to unlock the state, and SVSM can load the TPM, from the state can load the TPM state, the UEFI variables, the UEFI variables, and so on. Okay, so which are the challenges that we have? First, we don't have, and also we would like not to implement a network stack in SVSM. So since we need to talk with a remote server, yeah, we need to find a solution. And then we also want to support multiple attestation protocols. So our idea is to implement a proxy into the host. In this way, we will allow SVSM to talk with the remote attestation server, and essentially the proxy will forward all the requests coming from SVSM to the server using an HTTPS channel. And okay, which are the challenges here? So the application, the proxy that will run into the host will be completely untrusted. So it's a clear man in the middle. So the attestation protocol need to be aware of that. So need to, for example, generate asymmetric key to receive the secret and stuff like that. Also, the host can do some kind of, can change the URL of the remote server, or can change the proxy. But yeah, this for us is kind of denial of service, so it's not really affecting confidentiality. And another challenge is we need to define some kind of protocol, I mean, the channel between SVSM and the proxy. Okay, we did an overview of what we have. Now let's try to put everything together. So the first steps will be SVSM will boots up, as Jörg mentioned. Now we support IGVM, so IGVM will contain the entire initial state with including also the firmware. So we can, in this way, we can calculate we can easily calculate pre-calculate the launch measurement, hopefully. And at this point, SVSM needs to use the proxy to connect to the remote server. So sends the attestation report, receive back the key, and will be able to unlock the state and load the TPM state from it, and also the UEFI variable. Can continue after that. SVSM can continue the boot, launching OVMF, which can launch the OS using the secure boot and the measure boot. Then, since we have the persistent TPM, the OS can unlock. Can, for example, have the key, the root file system key sealed with the TPM, which is a stable identity. And so we can use the standard TPM and to unseal the standard tools to unseal the key and mount the root file system using also the PCRs. We did an intro now. Now let's go a bit deep into details and challenges. One of the last things I mentioned was the communication channel between SVSM and the proxy. So we need a device, of course. Our initial idea is to use a simple serial port. Our proof of concept is doing that, which is pretty easy to support, but for some use cases, maybe it can be slow. So another alternative will be to use a VirtIO VSOC device over MMIO transport. it will be more code in SVSM, but maybe part of it, like the vTPM transport, could be shared with the driver for the block device that Oliver will talk later. And our idea is to be not too tied to only on these two devices, but we can be generic to support also either hypervisor specific channel. Then, of course, we need to support the driver in SVSM, and we need to define the communication protocol over this device. Okay, now we need, about the remote attestation protocol, the challenges are we want to support multiple attestation protocol. This is one example that Tyler is working on. It is the KeyLime-T boot attestation, but yeah, potentially we would like to support several attestation protocols. Now the question is where to implement the attestation protocol. So the first idea is to, of course, implement it into SVSM. In this way, the proxies could be very, very, very simple. The idea is SVSM will generate the entire HTTP body sent to the proxy with just forward the request to a remote server. The problem with this implementation could be that every time we need to add a new attestation server, a new attestation protocol, we may need to, or we want to support multiple attestation protocol, we may need to have different binaries with different launch measurements, so it could be a problem. So another idea is to implement the attestation protocol into the host proxy. In this way, as the SVSM will be untouched. Of course, we need to define a more sophisticated protocol between the proxy and SVSM to negotiate a lot of things, but in this way, SVSM could be essentially stable, and all the complexity about the attestation protocol will be moved into the proxy. Yeah, another challenge is we talked about stateful TPM. So let's take a look on how the TPM emulation is done now in SVSM. So we have a libmstmp, which is a library that is mainly based on the Microsoft TPM reference implementation, which is written in C. So inside this library, we also have a little serial time library. And of course, OpenSSL, which is the main requirement of the Microsoft TPM implementation. So how to support the SVSM storage API with the Microsoft TPM implementation? One idea, which is one that we implemented in the proof of concept, is to extend the serial time we have in order to support also this libc API used by the simulator into the Microsoft TPM implementation. So fopen, fwrite, fread. So in this way, the idea is to implement that API to use the storage API exposed by SVSM. In this way, we don't need to touch anything inside the Microsoft TPM implementation, and we will use entirely the simulator code which is there. Another idea, this is pretty easy to do, but maybe a better idea could be to add a new platform into the Microsoft TPM. So essentially, the code base provides a way to support multiple platforms. One of these platforms is the simulator that we are using now, which is essentially really useful when you want to run on when you have a libc, a standard libc. But what we can do, we have also a lot of examples into the Microsoft TPM implementation, is to add a new platform and base the entire platform on the SVSM API. And for example, we can implement the NV memory read or memory write directly based on that API, and not emulating the libc code. And now back to Oliver.
Yeah, so storing the SVSM state on the untrusted host allows the host to do some nasty things with it. For example, it can attempt a rollback attack, so just feed back an old state file, which the SVSM would be able to decrypt normally and wouldn't detect that it's an old file. Yeah, that means that, for example, the TPM monotonic counters would be unreliable, and that everything that was saved in it would be gone or would be an old version. This could be, yeah, one attack. And another thing that they could do is, yeah, to clone the VM, and to spawn a copy of the whole VM with the state file, which would also boot up because everything is exactly as expected. The problem is then we would have the same TPM identity twice or multiple times, which is, yeah, not what a TPM identity is supposed to be. TPMs are supposed to be unique. Yeah, to mitigate this, you have to like think a little bit what to do. Like an easy idea would be to, against a rollback attack, is to add a boot counter that is kept on the attestation server and also in the state file. And then they have to be in sync and are compared when everything boots up, so that you can't refeed in an old file. And the clone attack is a little bit more involved to mitigate. So you would have to like tell the attestation server to only allow one boot at a time. So the user would have to go and prime the attestation server and say like, yeah, now I'm launching the virtual machine, and then the attestation server allows one attestation to go through, so that there are no unauthorized launches of VMs. This would be an idea to like, yeah, stop the cloning. Yeah, so storage drivers. So how we wanted to add a storage device to SVSM. We investigated two choices so far for which storage interface to use. So QEMU has this pflash interface that is already used by OVMF for the code and for the variables. It's rather simple to implement, but it's also unfortunately quite slow because you have to write individual bytes at a time almost. This could cause some delays if, for example, the vTPM wants to write out its full state at some point. The other option that I looked at is using virt.io block via the MMIO transport, which is, of course, comparatively fast. Yeah, and if we would implement this, then we would also get other devices almost for free. For example, VSOC. I mean, the most work of this would be to implement the virt queues and the MMIO transport. Of course, this is a much larger code base that we would have to pull into the SVSM. And yeah, we would require some small patch for QEMU to enable the MMIO slot in the Q35 model. Yeah, of course, in the end, it would be nice if we could support multiple different storage backends in SVSM, so to support the needs of different hypervisors. Also, the question was brought up, do we want to maybe agree on one common SVSM storage driver type that then all hypervisors would implement? I don't know if this is useful, but anyway, so there's a draft pull request that I opened that adds virt.io drivers crate from the RCoreOS to SVSM. Yeah, it was not too hard to integrate because the crate doesn't require the standard library, and it just integrated nicely. And it kind of works, but of course this is host-facing code and needs a lot of reviewing and testing. And we also heard earlier about securing the virt.io interface in the context of confidential computing. So yeah, there's some more work to do to make this really secure. Yeah, we prepared a little demo that you can try out interactively. So there's a repository that you can clone, and it includes everything you need to get this running. So this, when you run this demo, you will get the confidential VM that uses the remote attestation via the proxy that was described, and it uses the virt.io drivers to store an encrypted state file. Yeah, and it is able to seal and unseal secrets via the TPM PCR policies. I'm not showing this here because it's not much to see. It's more fun to like try it out yourself. Yeah, so our next steps and what's still to do. So on the storage side, we still have to think, do we need a little file system on top of this SVSM state, or is a simple partitioning scheme enough? We need to add more protections. So yeah, integrity protection, we haven't talked about yet, but the host could of course also modify the state file and cause some problems. Yeah, we talked about rollback and clone attacks, which we have to think about. Yeah, we need to decide on which driver to use or which storage backend to use. Yeah, for the remote attestation, it's like, where do we implement the attestation clients, in the proxy or in the SVSM? And also we need to decide on communication channels from into the SVSM. Yeah, that's it. And thank you for listening. And now we can answer questions.
Yeah, very interesting. This is more of a thought. I'm not sure it makes sense, but have you thought about opening a proxy through the client, through the host? Because in some situations, the host, the hypervisor and the host, and the remote attestation server belong to two different people. The host is on the management network, so you might get to it, but you have to do it in a roundabout way, and that makes network monitoring a bit more difficult because you allow customers to more or less talk to your host, which you normally don't do. Have you thought about doing the proxy through something running on top of the Coconut-SVSM, since technically it doesn't need to be trusted?
So what you are saying is that maybe we need to implement the entirely TCP/IP inside SVSM to talk with any kind of network?
No, not SVSM, something running outside of SVSM. So you're doing the proxy through the host.
Yeah.
And it's not trusted.
Right.
Can you put something that's trusted on top of the SVSM in another VPML, so for example, that can do the connection to the host? It can have the network stack in there. Since it's not trusted, it doesn't really matter.
Yeah, we can do that. The problem is we need to talk with the server as soon as possible to load the state. So to load the TPM state. So we can also do in SVSM implementing a user space stuff, but our main concern is we don't want to bring TCP/IP and stuff like that into. So we always, in that case, we also need to go with a proxy. Otherwise, the other solution is just attack a NIC into the SVSM and then implement the entire stack.
So my idea is to move it completely out of SVSM, put it on, yes, call it a service OS that you don't really trust. And then it will do the connection.
Okay, but which kernel will run there? Is a Linux kernel? What?
Whatever kernel. It can be another VM, just something that does connection. So what I'm trying to avoid is passing through the host, which in some cases might be problematic because it's in a management network and you don't want to allow customers to connect via the management network.
Yeah, I think it's doable. Yeah.
All I'm saying is that another VM is an interesting idea if it is not too complex. Just run the proxy there, and then we don't have to build in SVSM. I don't know how difficult it is.
I don't know. It's just I'm just thinking on the fly here.
Yeah.
You want to ask a question, Fabiano?
We start to have like a chicken egg problem then, because if you want to have like a trusted internet connection to make sure that your trusted VM is okay, like how do you trust the first trusted VM that you want to start the internet connection in that, right? So that's the part that I guess gets a little bit messed up.
Yeah, but I mean, we are seeing that there is some convergence towards allowing multiple what we're calling it again. It's not VMPLs any longer, but I mean the more general concepts of partitioning, right? I mean even in cases where confidential hardware is not available, so maybe there is a way that we can bundle. I mean a confidential guest with a confidential with a trusted SVSM, but with a non need to be trusted sidecar VM that can take the role of being the proxy, a very simple, stupid VM that is untrusted, that is only can only communicate with the SVSM and vice versa, and the SVSM can make that part of the TCB to make sure that this is the case, but only communicates with this secondary sidecar VM to do the proxy, and then we don't need to do anything about the host. Things like IGVM, right, and partitioning of that needs to be available for us to do that, right?
Can you please go back one slide to the next steps thing? The attestation client in the proxy, I'm not a big fan of that idea. What I would like to treat the hypervisor interface just to be an untrusted communication channel, and everything that we need to trust should be inside the SVSM. I think it's not going to be a big issue because we can implement an attestation protocol as a user space process probably, and it will be bundled up for each hypervisor differently anyway. So each hypervisor can choose which protocol to use. So
do you mean that the channel between proxy and SVSM will be just an HTTP proxy at all?
Right. So whatever attestation protocol gets implemented, we just rely on an untrusted channel to the proxy, and the proxy is just a dump tool that basically does the VSOC or serial port to network translation, and everything else happens basically inside the SVSM.
Yeah, it was our first idea. The second is just if we want to avoid if we want to make SVSM generic enough to support any kind of proxy without touching SVSM. This was the pro and cons of the two.
Yeah, right. And for the communication channel, I think that can be flexible as well, or it has to be flexible to be cross-hypervisor. I'm fine with choosing a default one per hypervisor, but yeah, it doesn't really matter whether it's serial port or VSOC, or I don't know what Hyper-V provides, but yeah.
In theory, they also have some kind of VSOC.
Yeah, I think it's called VMBus there, but yeah, it's something similar. So
yeah. By the way, I agree. We need to be hypervisor agnostic and support several drivers with that, like for the storage.
Right. It's the same is true for the storage. We need to be also flexible on that side. My remarks.
Just one comment about the proxy, if I may. We have to make this like in a way that this is like plug and play with any kind of. You guys started playing with this with Keylime, but I just imagine this like going to the distros with Keylime, and then like someone else wants to add their own, and it just may take like 6 months so they can get this into production, right? So any kind of a plug and play mechanism that can just allow someone to drop something there and be able to use their own, that would be needed.
That was the idea, to move the attestation protocol into the proxy. So in this way, you don't need to touch SVSM at all. You just need to implement whatever you want into the proxy, and that's it.
Klaus.
I just wanted to reinforce, maybe the sidecar thing, sidecar VM could be really interesting with the general mechanisms for us having, in the same VM, even for cases where the confidential hardware is not available, scheduling, one particular VMPL 0, VMPL 1 or 3, 1 or 2, and then, we could delegate to that untrusted VM to pretty much do anything they want. Have a freaking network stack, have a proxy, have even be completely controlled by someone else that decides who they need to talk to, because we can guarantee who they are talking to at the SVSM level as part of the TCB.
Yeah.
And then, I mean, how that message comes across and in what format, in what protocol it comes across, it can be completely untrusted then.
Yeah, it's exactly like the proxy, right?
Yes,
the only
a proxy that is only part of the single IGVM image.
Yeah, right.
Right? Instead of us actually requiring changes to the hypervisor to the host.
Yeah, instead of providing just an application, we need to provide like the entire VM to package somewhere.
Yeah.
Yep.
Yeah. So one challenge with putting the attestation clients in SVSM is that you now get tied to a particular attestation protocol. Today it might be Keylime, tomorrow something else might come up, maybe something using RAT's framework. So maybe the sidecar thing might be the way to go so that you're not tied to anything in particular. So SVSM becomes neutral. You push everything that is dependent on any particular protocol or communication protocol.
Yeah, it will be, I mean, it's exactly the proxy running in a different VM instead of the host. Will be, I mean, the proxy will be exactly the same, just what we will change is where it runs.
Yes.
Yep. It's over. Yeah, we are out of time. Thank you.